Okay guys, this is chapter 18, chapter review and standardized practice test. Make sure that you've gone through this on your own first, and then turn this on, this video on, and go over with me, okay? It's very important that you did this on your own first. Okay, 26, a compound composed of two elements, binary compounds. 27, a molecule with partially charged areas, polar molecule. 28, a positively or negatively charged particle, ion. 29, a chemical bond between oppositely charged ions. That's ionic bond here, opposite, plus, minus, right? 30, a bond formed from shared electrons. That's covalent bond. Skip 31. 32, a particle made of covalently bonded atoms. That's molecule. Number 33, it indicates how many electrons must be lost, gained, or shared to achieve stability. That's oxidation number. Number 34, shows which elements are in compound and their ratios. That's chemical formula, like these, right? It tells you which elements are in a compound and which ratio. All right, 35, what do you have? This is easy. C, noble gases. And I'm kind of going fast because I'm just telling you the answer. And there'll be time when I will be solving question. But, you know, if you think I'm going too fast, pause and just try to catch up, okay? So, like 36, what is the name of CuO? We know Cu is copper. Let's do this. Cu is copper. Okay, copper, right? O is oxygen, but we have all these variations. Which one is it? Okay, I already told you that there's some transitional metals. They have oxidation numbers that varies. Sometimes 1, sometimes 2, sometimes 3, and they're shown in parentheses with Roman numerals, right? And in order to find out, we have to find out the oxidation number of the oxygen here. And the oxidation number of oxygen is its valence electron minus. I mean, the valence electrons that it's needing, which is 2. Oxygen is negative 2. Okay, in order to balance this out, we need 2 plus 2 oxidation number on copper. Does that make sense? So this is the same thing as 2 plus. Then they cancel out. So the answer for the 36 is C. 37. Which of the following formulas represents a non-polar molecule? Okay, first of all, polar molecule. So it's a covalent bond, right? So something like C doesn't make sense. It doesn't make sense, right? And then it's non-polar. Okay, polar means there's partial charge. Okay, the electronegativity between the elements are different. Do you remember that exercise? You know, the bigger the atom, it has more electronegativity, and you need to minus that, right? Then you get the difference. Now, non-polar means it's same. It's a equal sharing, so it must be A, right? Nitrogen, nitrogen. They must have the same electronegativity, and when you minus them, it'll be 0. Okay? We're going to use this for question 38. How many electrons are in the outer energy levels of the highlighted group of here? Okay? Obviously, this is a noble gas. This is needing what? 1 more, so 7. That is the valence electrons on the outer shell. 39, which is a binary ionic compound? Remember, binary, it means 2 elements, but it's ionic compound. Okay, so there are more than 2. Here is only 1. This one. This is ionic. Sodium is ionic, the metal, and fluorine is non-metal. So B is the right answer. Skipping 40. 41. Which of the following is an atom that has gained an electron? Okay, you might want to go with molecule, but it says which of the following is an atom. Atom. It's not a compound here. Okay, it has gained electrons, so it'll be negative ion. Which of these is an example of a covalent compound? Covalent. Remember, covalent is sharing between non-metals around here. Okay, not anything from here, okay? So let's look at this. Sodium, no, that's metal. Calcium, no, that's metal too. Another calcium. Here, sulfur. Yes, sulfur is non-metal. They're in this group together. So this D is covalent bond, covalent compound. Okay, we're skipping 43, 44, everything here. Am I? Yeah, I'm skipping everything. Skipping everything on this page, okay? Everything on that page. Going to standardized test. Okay, 1. Which element is not part of the compound? Whatever that is. It's nickel, right? That's nitrogen and hydrogen, nitrogen again, and oxygen. So B is the right answer. Aside from hydrogen and helium, when an atom is chemically stable, how many electrons are in its outer energy level? Okay, some of you might have said A, but D is the correct answer. It's asking how many electrons are in its outer energy level. The outer energy level is all filled, right? So there's 8 of them. So D. Okay, now we're using this for number 3 and 4. What type of bond holds the atoms of this molecule together? Fluorine and hydrogen. They're both non-metal, so it is covalent. Okay. Which statement about this molecule is true? This is a non-polar molecule. That's wrong, okay? Because look at their size. They're different, okay? And they're not sharing equally. I'm just going to go to the right answer, D. This is a polar molecule, right? Polar. Because molecule means they're covalent bond. They are. And polar means there's a partial charge. One is bigger, one is smaller. So it is pulling more electron on this side. It's not equal. Okay, 5. What is the oxidation number of sodium in the compound this? Okay, I don't know how to read that. I could look it up, but I don't want it. Well, let's look at that. That looks like what? Polyatomic ion that we talked about. So PO4 right here, that's phosphate, right? Phosphate has oxidation number of -3. Okay, so that's important. We need to know that. So let's go here. Phosphate. That together has oxidation number of -3. Sodium, if you know, sodium has just one, +1. +1, right? In order to, here, like that, okay? Phosphate has oxidation of -3. Sodium has +1. So in order to balance this out, since it has 3, I need to have 3 of sodium. So Na3, and then I have PO4, right? This one. Right? So the question is, what is the oxidation number of sodium in the compound here? What is the oxidation number of sodium? Okay, altogether, sorry, I'm not looking at the camera. Okay, oxidation number of 1 sodium, this is a little confusing. Okay, don't worry, it's not going to be on the test, but just for your understanding, for 1 sodium will be 1 plus, but all together, because there's 3, it'll be 3 plus. Okay, but the real correct answer is C. Okay, 1 sodium, A sodium has +1. Together is 3 plus. Okay, don't worry about that, okay? That will not be on the test, but just understand. All right, let's look at this for, this is for number 6, 7, 8. Which element is least likely to form an ionic bond with the sodium? Which one is it? Argon, right? Number D, that's noble gas. That is not going to make any compound. How many electrons are required to complete the outer energy level of phosphorus atom? Let's see where the phosphorus is. Phosphorus, it's right here in group. Phosphorus is needing 3, okay? It's needing, oxidation number is 3. It needs 3 more electrons. right? So let's look at that. How many electrons are required to complete the outer energy level? 3, C, okay? 8, how many electrons are in an argon atom? Haha, what did you have? Did you have A? That's wrong. It's 18, okay? It's not asking valence electron, okay? But it's asking how many electrons are in an argon atom, the whole number of electrons. So if you look at here, argon is 18, right? 18. That's number of proton, but atom has the same number of proton and electron, okay, if it's not charged. All right, number 9, what do the group 17 elements become when they react with group 1 elements? So we have group 17. Let's make this a little bit smaller. Okay. So we have group 17 here. It's always needing one more valence electron. When it reacts with group number 1, the ones that want to get rid of one, what do they become? What do they become? That's the question. Let's see. They become negative ions? Do they become neutral? No, they don't become positive. They don't become polyatomic ions. It's A. 10. What is the name of, whatever that is? Okay? So, we know when you see something like this, you have to think about, that must be polyatomic ion, right? So, you know the first one is potassium. Okay? And what is that? So, you need to look for that. You need to look at a table, and don't worry because this table is going to be given on the test. All right. So what was that? C2H3O2. Oh, that's acetate. So the answer for 10 is potassium acetate, B. Got that? How many electrons are in the outer energy level of helium atom? Helium and hydrogen are the only ones that have only one energy level, which is one energy level, right? Hydrogen has 1 and is always needing one more. Helium has 2. It's filled, completely filled. It's very happy. So how many electrons are in the outer energy level of helium? The answer is B, 2. Okay, the last ones, 12 to 17. Okay, so use this figure for answering 12 and 13. Okay, describe the trend in the oxidation numbers of these period 2 elements. Okay, we have nitrogen, oxygen, fluorine, neon. They are all in period 2. What does that mean, period? Okay, period, it goes period this way, right? Period. And this is a group number, right? So they're all in period 2 here. The second row. This is the first row, second, third. They're all here, right? And if you look at it, neon, fluorine, oxygen, nitrogen. Neon, fluorine, oxygen, nitrogen. It's going this way, right? And it's going, down. And what's happening? Well, here's the oxidation number. Okay, neon's oxidation is 0. Fluorine is -1. Oxygen is -2. Nitrogen is -3. Okay, it is just showing the oxidation number. Okay, neon is a noble gas, needing nothing, is 0. It doesn't need anything, 0, right? And fluorine is needing 1, so oxidation number is -1. It's needing 1. Oxidation number is 1. Oxygen is needing 2 valence electron. Here, oxidation number 2 is same thing as how many valence electron is needing, and so forth. Okay. As long as you just understood that, that's fine. I am not asking that kind of question on the test. Number 13, why do the oxidation numbers of nitrogen and fluorine differ? Well, oxidation number of nitrogen and fluorine, why is the oxidation number different? Because their valence number, their valence numbers are different. They're needing different numbers of valence electrons. So they're in the say a different group. Obvious question. Okay, nothing complicated. 14, draw electron dot diagrams for carbon and hydrogen. Okay, so let's draw that. Oopsie. So, okay, carbon, we are going to draw let's see, carbon. Where's carbon? Number 14. Carbon has 4, right? Okay. Hydrogen is 1. Okay. And then draw a dot diagram for methane. Methane is CH4. Okay. Yeah, CH4. How are we going to draw that? Well, simple. Okay, we're going to have the first one. Don't forget about that. First hydrogen attached here. Second hydrogen. Third hydrogen. Fourth hydrogen. Okay. So that will be the dot diagram for methane, CH4. 15. Give several examples of ionic compounds. What are 2 properties often shared by these compounds? Well, there are many examples of ionic compounds. The most classical ones that we always use is sodium chloride. Okay, sodium has 1 oxidation plus 1 chloride, right? Ionic compound will be NaCl. Another one, potassium and iodine. Okay. And what is it asking? It's asking, what are 2 properties often shared? Okay, so if you look at page 63 in your notebook, okay, it's hard to see, but I wrote it down here. These are the properties. Ionic compounds. The 2 properties are, when they become compound, they become crystalline solids. Okay, that's all you need to know. You don't have to memorize. I mean, what is a crystalline solid? I'm not going to go into that. And they have high melting points. Okay, high melting points. Okay, the last one. What information is given in a chemical formula? All these chemical formulas, right? Where are they? Like this, chemical formulas. And this chapter is all about chemical formulas, right? What information can we get from chemical information formula? Well, it's same question as 34. Same question. Shows which elements are in a compound and their ratio. That's chemical formula. So what kind of information can you find out? Well, the type of elements that are in a compound and their ratio. Okay? Wow. That's another 17 minutes of study. All right, good luck. Okay, bye.